Hello, you're looking at Mr. Chua with a pendulum. The styrofoam cup is there just to provide some damping force to the system. And the optical pins are there to help Mr. Chua maintain a constant amplitude of the driver. By swinging the string periodically, he's providing a periodic driving force to the pendulum. Since the driver is driving at the natural frequency of the pendulum, he's transferring energy very efficiently into the pendulum. Since energy is continuously being fed into the pendulum, you see the amplitude of the pendulum increasing gradually. But at the same time, the pendulum is losing energy to the surrounding. Why? Because of the paper cup, it catches quite a bit of air resistance. And the rate at which energy is lost to air resistance increases with the amplitude of the oscillation. This is why the amplitude doesn't increase forever. Eventually, it will reach a final, steady amplitude. And we have marked this final amplitude with that green rectangle. And Mr. Chua is now back with the same pendulum, but with a smaller styrofoam cup. And just like before, he is going to drive the pendulum into resonance. But this time, do you think the final amplitude is going to be larger, smaller, or same as before? Realize that while Mr. Chua is doing the work to input energy into the oscillation, energy is also being lost to the surrounding due to air resistance. It looks like we have already exceeded the amplitude achieved when we were using the larger styrofoam cup. Let's give Mr. Chua some time to confirm that this is the final steady amplitude. But do you understand why we can achieve a larger amplitude than before? Are you ready for the answer? With a smaller styrofoam cup, the amount of air resistance encountered by the pendulum is smaller. This allows the oscillation to reach a larger amplitude before the rate of input of energy by the driver is matched by the rate of energy loss to the surrounding due to air resistance. So the amplitude reached by the pendulum with the large styrofoam cup is marked with the green rectangle, and the amplitude attained by the pendulum with the small styrofoam cup is marked with the yellow rectangle. Now Mr. Chua is back again with the same pendulum, but this time there's no styrofoam cup. Once again, he's swinging the string at the natural frequency of the pendulum. What do you think is going to happen? We have already exceeded the resonance amplitude for the large styrofoam cup. And we have even exceeded the amplitude reached by the pendulum with the small styrofoam cup. And the amplitude is still growing. Without the styrofoam cup, the pendulum is encountering very little air resistance, so it's practically undamped. Mr. Chua continues to pump more and more energy into the system, and the system is not losing much energy to the surrounding. So the amplitude of the oscillation keeps growing and growing and growing, until eventually when the oscillation is broken for one reason or another. Hope you found the video useful. Ta-ta!